You know, it's been a little, but I finally had enough time to record my next geometry video. Today we'll be talking about the first part of parallel lines and transversals. And I still gotta get the angle first, so yeah, stay tuned. You might never see them, I'll just, you know. So, do you recognize a geometric object or diagram which looks like this? You may or may not have learned it. I remember learning it like in 6th grade. Technically 7th grade math, but whatever. Point is, this is kind of what parallel lines and transversals are. Parallel lines and transversals. Now, you might have been... Why is it echoing? Okay. But anyways, you might have been asked to find the measures of these angles. You might have been told angle 1 and angle 8 have the same measures. 8 and angle 5 because they're vertical angles, and so do angle 4. Like, you will only be given one angle. Maybe 2. I don't know. You may have not even learned this. But these are parallel lines and transversals. So let's just talk about one of the most important features of this unit. Parallel lines. This is mostly talking about parallel lines, but it's a really quick introductory with non-parallel lines. So, there are 2 ways to say lines are parallel. So let's say this is line L and this is line H. First way to say they're parallel is L, 2 lines that look parallel, H. This is the parallel symbol, and that just says 2 lines are parallel. And this is another parallel symbol, but sometimes they're on the line. So anyways, this tells us that the 2 lines are parallel. So what do parallel lines mean? This is an Algebra 1 topic. So if you do not remember this, you might want to go back to Algebra 1. Not really, because it is reviewed. But parallel lines are lines that have the same slope. It's literally it's as simple as that. Or in other terms, are lines that will never meet. So when lines don't meet, that means they share no common intersection points. In systems of linear equations, which you should have done last year in algebra, you knew when we find a system linear equation, there are up to infinite solutions. There was 0 solutions, 1 solutions, and infinite. Infinite being the lines are coinciding, basically meaning the lines are the same. 1 solution being the lines just have one common distinct intersection point, and 0. These are parallel lines. In a system of linear equations, the lines will look like this. Y equals 3x, y equals 3x plus 4. Notice how they have the same slope. When 2 lines have the same slope, that means they both have the same constant increase, but at different points. Think of it like this. You and someone else are running at each other the same amount as 60 miles per hour, constant. There's no change. Let's pretend this hypothetically. You both ran exactly 60 miles per hour. So this is little old Tommy, and this is little old doggy. Yet they are both running 60 miles per hour. Will one overtake the other? No, because they're running at the same constant rate. That's linear equations. Systems of linear equations. Think of it like this. These are both running at the same amount of speed. One cannot get past the other because they're running at the same amount of speed. So let's talk about the different line relationships. So in systems of linear equations, you learn about parallel lines. You learn about perpendicular lines. And you learn about lines that just intersect. These are perpendicular. That means they form a 90-degree angle at their intersection. These are parallel. That means they never meet, denoted by the little arrow symbol, or just a symbol, or it just says they're parallel. And finally, we just have intersecting. These are the most basics, and these form vertical angles at their intersection point. Vertical angle proofs will be discussed as we go on, or in another video. I'm going to tell you decide to release it. But there is another one we haven't talked about yet, and this is because they're different. So let me make my best attempt at a shape. So I want to discuss quick. This video isn't going to be as long, so I showed you this little, what I would call an angle tangle. This will be next video as we learn the different types of angles. That was a pen, by the way. if you hear that. We're talking about skew lines. Lines. Same plane. So my teacher gave a perfect analogy. Well, let's say you're in a house. Yeah, I'm stealing this for her. House. Let's say this is our roof. Wow. And this is the ground. Roof. We have a line on the top of the roof. What is that? Have a line on the top of the roof. But then we have a line down here on the plane. Will these lines ever meet? No, because they're on two different planes. What the? And if the planes don't intersect, don't mind that in the background. If the planes don't intersect, then what's happening? The planes don't intersect. Then how will the two lines get out there? A plane extends to infinity in all directions. If you don't remember that. So that means if the two planes don't cross, they never will cross. Because remember, they extend to infinity, so the lines will always stay on the plane. The line the line never leaves the plane. So there's this little diagram. It looks something like this. A, B, C, D, E, F. Now, so I'm going to go here and name some skew line relationships. A, D, and C, F are skewed. You see, they're on different planes. This is on plane A, B, D. This is on plane B, C, F. They will never meet on two different planes. However, what if two lines never meet but are on the same plane? So let's say AD and BE. Remember, if there's 2 points between any two points, there is a line. So AD and EF. These are both on the plane ABD. Because they are both on the plane, that means they can intersect, but they aren't. These are what we call parallel lines. So, yeah, that was basically kind of... I'm not going through all of them, because that could take like a few years. I was like, I don't know, I released a new AI tool, so that's cool. But that's basically a simple introductory to parallel lines and whatnot. So, I suggest before moving on to the next video, you take a second and look through this. Just understand everything. That's what I'm... Understand what this looks like. Understand how these lines are parallel. Understand different types of intersections, why lines with same stuff are parallel, and the different types of intersections. I feel like I'm forgetting something. If I forget something, I'll like the row and the video, like stuff I forgot while teaching perpendicular and parallel lines. Okay, but that shall be it for this wondrous video I have finally released a new video. Now, let's do the challenge question. This is like a little review. Solve the system I'll stop the video now, but you can go and try to solve it. Any method will work. See ya.